Hello, in today's alchemy video, I've made a discovery I'd like to share with you. Earlier today, I picked quite a few berries from a rattan vine, also known as Alabama Supplejack. And these berries are somewhat edible, but they have some tannic acids and they don't taste really very good. But I thought, well, I'll grind them up in a blender and then mix it with some water and make like a dye out of it. And during that process, I discovered that it does react with bases or acids to have a color change. So it could function as a pH indicator. Let's do an experiment and I'll show you how that color change can occur. We're just going to take some warm tap water. I came in the bathroom here because the contrast of lighting is a little better with this white sink. I'll take a little warm water there. Warm water here. There we go. And then one of these will make the pH acidic. Make it acidic in one and basic in the other. I just have apple cider vinegar, which is kind of all the vinegar I have right now. And we pour a little bit into here. No problemo. Make that one acidic. All right. And I have another alchemy project I'm working on that has I've got a lot of potassium carbonate and hydroxide salts from fireplace ash. You'll see another video on that in the future. But these are the hydroxides and carbonate salts from ash. And so it's alkaline. If I put that into this little jobby here, kind of sketchy the way I'm dropping those in. I have to set the phone down a second. Okay, and if I give it a shake, you can see there's that potassium carbonate at the bottom, along with other hydroxides and carbonate salts. I'm just going to give it a quick shake to make sure it's good and alkaline in there. Not all of it will dissolve, but that's okay. Now, using the juice from the berries of the supplejack vine, the Alabama supplejack, I'll put 2 half dropperfuls into the vinegar mixture. All right. And notice it's got a bit of a color change there. And then I'll do the alkaline mixture. Same stuff right away. And so it doesn't take long, and you can see quite a noticeable color change. The acidic solution is going to be more of a rose or a pink kind of a color, and the alkaline solution turned almost a midnight blue, almost like just black. And I think if it were somewhere in between, it might be, I don't know, somewhere in between. So this substance could be used as a pH indicator. It may not be the most effective pH indicator, but anything that gives you a color change like that straight out of nature definitely has some kind of use. Something you want to know for experiment purposes. And getting a good strong color from adding this. It tended to taste kind of like tannic acid, so it's probably a little acidic. It's not, like I said, you can't really eat the berries, but they're not poisonous per se, so no problems there. And maybe if we mix these two, we can see somewhere in between what the pH would be in between, if there's any. Man, look at that. It's like black. Midnight blue, blackish kind of color versus a rose color. Let's put just a little of this in there. And then that might be a bit much. Okay. Yeah, this stuff's strong because that ash is really strong. We'll add a little of the vinegar to it, see if we can, see if the color does something in between. What happens when the pH is somewhere in between? It's still like black like that. Maybe the tap water is a bit alkaline. Maybe if we get rid of some of this vinegar and add just a little cool tap water, we can see a bit of a color change, perhaps. Not really. You know what? Let's get rid of that. Let's just do straight tap water and see, because it's got a pH around here pretty high. It's like 8.5 or something. A lot of limestone in the soil. We'll see what tap water does. Okay, so it's kind of a darker purple. Definitely not that rose color we saw with the vinegar. Yeah, it's kind of it kind of gets like a muddy, dark purple color. The more alkaline it gets. That's interesting. Okay, well, that's enough for today. Appreciate you. Have a good one.